Hello everyone, we produce innovation materials. Let's take a look at this building material in more detail. The main basis of this material is concrete, but it's not a simple concrete. It's filled with hollow air cells. Because of this, it acquires a number of useful advantages, such as low weight, high temperature resistance, high noise isolation, low thermal conductivity. Due to the closed structure of an air cells, the capillary effect of concrete is reduced, which means that the wall of this material will absorb less moisture in comparison with classic concrete block. In our material, various chemical additives are used, which increase the limits of dynamic and static loads, betray the high temperature resistance, antifungal and antibacterial properties. Also, our material is dispersion reinforcing. This can be seen with the naked eye. You see these protruding hairs? This is polypropylene fiber. Interlacing in the structure of concrete, it makes it stronger over 40%. The second sample is the same material, but it has one differentiation. You see those white dots? Those are expanded polystyrene granules. With these granules, material becomes stronger. This means that you need to apply more compression forces to destroy it. Also, due to the fact that the plastic granules do not absorb water, the material becomes more hydrophobic. The thermal conduction of the material remains the same because the granules consist of 87% of air. Also, thanks to the concrete shell around, they do not burn. Since the granules are elastic, it can be said that this material in some way becomes elastic. This means that during the dynamic load, the granules absorb the force of the heat to themselves, preventing the cracking of the concrete structure of the material. Now we will test the strength of such materials: thermoblock, traditional cement block, our material type A, and our second material type B. We also decided to test the strength of a fragment of a clay brickwork. Let's check the impact resistance of material type A. And now let's check the impact resistance of material type B. Consider a sample of other material. which is produced by other company. This material is made by another method and the main heat insulating component is expanded clay. According to the manufacturer, it is strong, with low thermal conduction and does not absorb water. We will check this first. Let's start with its strength. Now consider the classic building material. It is a hollow cement block, made by semi-dry pressing. Its parameters of dynamic loads, thermal conductivity and moisture resistance leave much to be desired. Let's start with its strength. And now let's test the strength of the classic brickwork. To test the thermal conductivity, we created improvised tiny houses. One of them is made from classic Portuguese brick and another from our type A material. The wall thickness of the house from our material is 3 cm. The wall thickness of the brick house is 4 cm. Inside both houses we put hot coals, the temperature of which is above 600 degrees Celsius. And now we will cover them with lids and leave them in this condition for 10 minutes. You see that the initial temperature of the external surfaces is the same. After 10 minutes, we check the device on a neutral surface. The outer surface of the brick house rose to 187 degrees, which is 158 degrees higher than the original temperature. The surface temperature of the house of type A material has risen to 62 degrees, which is 33 degrees higher from the original temperature. The indicators of the device, we can conclude that the type A material is almost 5 times more effective in terms of thermal conductivity than the usual classical clay brick. Now imagine how much money you save with the house built of our material on heating in winter and cooling in summer. Let's take a look inside of our houses. We can clearly see that the temperature of the coals inside the house from our material is 60 degrees higher. I can easily take with my bare hands a house in which there is a hot coal with a temperature of more than 300 degrees and not get skin burn. And now let's check the thermal conductivity of type A material. And now let's check the thermal conductivity of classic cement hollow block. And now let's check the thermal conductivity of thermoblock. You think that we are afraid to show the thermal conductivity of the material with polystyrene balls because they will burn? We have nothing to hide from you, look! The temperature on the one side reached 400 degrees Celsius and on the other side remained the same. The difference between the temperature was 381 degrees and the distance was only 2 centimeters. Of course, the unprotected layer of polystyrene granules burned down, but the granules inside were not damaged. And now let's do a little test with water. Here we have ordinary tap water, and for greater clarity we added a blue pigment. We poured the same amount of water into 2 plastic cups. Take a sample from the classic thermoblock and check the words that it is moisture resistant. Its thickness is 8 cm. Also take for comparison a sample of our material type B. Its thickness is 3.5 centimeters. Now, with this thin stream, we will pour water onto the surface of the sample, and we clearly see that the water is completely absorbed into the material. Now pour water on our type B material. You see water drops rolling off the surface, leaving only a wet mark behind. Our material absorbs a minimum of water, but you can say that it's not fair because our material has a smooth surface. We took another test with a sample that does not have a smooth surface. So you can see everything with your own eyes. I hope you don't need comments.